In this video, we're going to discuss Euclid's Book 1, Proposition 9, and I'm going to try to do this so you can actually see me live in action as to how I'm doing everything. And we're going to start this way. Euclid starts this proposition by having us construct an angle. Now, I'm sure you probably remember from a previous video where I said, okay, if you take two rays and you put them together, you're going to form an angle. So we're going to make two rays right here. Now we're going to kind of pause back and forth. Now I guarantee you this is going to be more than one video, so bear with me. There's going to be a two-parter on this. Alright. Now, we have point A, point B, and point C. Now I'm going to back this up a little bit so you can actually see. Whoa! There's points A, B, and C. Alright, then Euclid says we're going to pick a point D. And I'm going to pick one right here. That's going to be point D. Now, he says that he wants a point E on this line right here. This is line AC. He wants a point E, and he wants the length between A and E to be equal to AD. Now, do you remember how we did that? Well, we've done this once before. In another video, we sure did. Actually, it was in proposition number 5 when we actually did this. And hang on just a second. My camera is being a real pain in the Watusi here. Alright, so how are we going to do this? Well, first of all, we're going to take our compass here. We're going to put the center D and the outermost part A. And guess what? We're going to draw a circle. That's exactly what we're going to do. We're going to draw a nice little circle here. Alright. Now when we do, we're going to extend this out and we're going to have a point P. Okay? So we're going to draw a little line between point D and point P. So far, so good. And now I can safely show you that AD right here is equal in length to point DP. And the reason why AD is equal to length DP is because, and I know I'm stuttering here, AD equals DP because all radii of a circle are equal. But that's not the end of it for us. No, sir. Next, normally we would draw an equilateral triangle. I'm not going to draw the equilateral triangle simply because it would be very messy and I don't want to have messy here, so we're going to just simulate the equilateral triangle that we would normally draw. Alright? So what we would do, I will draw the two circles that will make the equilateral triangle, but I'm not going to draw the triangle itself. Alright? We've already got the AD point. Got that circle pretty much pat down. Now we're going to draw another circle, and I'll back this up a little bit. It's going to be from point A, which is the center, point D, which is the outermost edge, and bear with me, we're going to draw that little circle. Okay? And where those two lines intersect, those two it's circle circumferences. Where those two circle circumferences intersect, we're going to have another point. And we're going to call this, let's call it point G. Alright? Now, we could draw out point G. Okay, but we're not going to. We're just going to draw. Now, normally we draw a line from point G through point D out to here. Okay? we're just going to simulate this. We're going to draw it out here. We're not going to draw inside because there's going to be another line inside here that we will draw. Okay? And we, of course, could draw this up here. And we're going to have a line that's going to go through point G all the way through point A. And it's going to kind of extend out like this. Okay? Now, we're not going to draw the rest of it because if we do, it's going to interfere with what we're trying to do at this point. Alright. Now we're going to take our compass again. Centermost part G. Okay, now, before we do that, we're going to back up a step. We're going to actually take our compass and we're going to put it on centermost part D, outermost part P, and we already drew this circle. And now we're going to have another point, and it's going to be point H. Now I'm going to show you this so far. Alright. Now remember, we drew an equilateral triangle, or we simulated it. It is going to be from GD to GA. Okay? And we drew it out a little bit further, so we had GDH, and we got GA, and we haven't got a point up here yet, but we will. Alright? Now, let me get my camera set back up here. Oops. The wonders of modern technology here. Okay, now we're going to take centermost part G and outermost part H, and we're going to make another circle. And you know we're doing proposition 1, 2, and if you didn't know, we are doing proposition 1, 2 to do all this. And that's how we're going to get another point called I.